This video is going to focus on a few examples of using the fundamental theorem of calculus, which you've seen from the previous video, and that connection, that beautiful connection between differentiation and integration that it gives us. So let's look at some specific examples here. We want to find the derivative with respect to x of this function here. So if we understand what we've just seen for the fundamental theorem of calculus, we will see that we don't need to go through the process of integrating this expression with respect to x, with respect to t, then substituting x, substituting 5, subtracting, then doing the derivative. All of that is a waste of time, and in fact we understand that the derivative with respect to x of this thing here is just this thing here, but as a function of x. So 4x plus cos x. Isn't that a lot simpler? Part B. This one's a little bit different. In this one here, we haven't got from a to x, the normal formula. We've got from 0 to 5x squared. Now this is important because this thing here is not just x. So if that was 2x or 3x or any function of x, then we need to take that into account in our answer. So what I'm going to do here is let's define a different variable, which I'm going to say is u is 5x squared. And we're going to use the chain rule here. So du dx is 10x. You're going to see how that applies now. So this original thing here is going to become the derivative with respect to x of 5x squared 0 sine 2t dt. And now what I'm going to do is use the chain rule here, the chain rule. So the derivative with respect to x, let's do this in a different color. The derivative with respect to x is the same as the derivative with respect to u times du dx, correct? Okay, so I'm going to change this thing now to say the derivative with respect to u of the integral from 0 to u, which is 5x squared, sine of 2t dt. And now to make this all fair, we know that the derivative with respect to u would have to times by du dx. Okay, so now you can see that this times by this will give us the derivative with respect to x. Okay, so let's do it now. This part here, we know from the fundamental theorem that that is just going to be sine of 2u. Okay, it's no longer a function of t, it's now a function of u, but we also have to replace du dx, which we know from up here is 10x. And we know u is 5x squared. So I've got sine 2 times u, so sine 10x squared times 10x, and I can just tidy that up and say that that's 10x sine 10x squared. Beautiful. Now if I wanted to do this the long way, let me show you the long way for this question here, just to convince you that this will actually work. If I did the integral of sine of 2t with respect to t, I would get the integral, the derivative of sine is cos, the integral of cos is sine, so the integral of sine is actually negative cos, so I'd get negative a half cos 2t. And this is between 5x squared and 0, and we want the derivative with respect to x of all of this. So I've done the integral of sine 2t. I'm now going to substitute 5x squared, so negative a half cos 5x squared in there will be 10x squared minus negative a half, and now I substitute 0 in there. Cos of 2 times 0 is cos of 0, which is just 1, so that's just going to be negative a half. Okay, now we're going to do the derivative with respect to x. The derivative with respect to x of this thing is negative a half cos 10x squared. The derivative of cos 10x squared is going to be negative sine 10x squared times the derivative of 10x squared, which is just 20x. And the derivative of minus half at the end is just 0. So what do we have? Negative a half. These two negatives here will cancel out. A half of 20 is 10, so we get 10x sine 10x squared. Okay, so I hope you can see from that that you definitely want to choose the method that I've got over here on the right hand side of the page rather than the left hand side of the page. Let's apply this now to a few definite integrals. Really simple. Here we're going to actually do the integration and substitute in 6 and 0. The equivalent of this question is, what is the area under this curve between 6 and 0? So here's a definite integral. So the integral is 3x cubed over 3. So that's just x cubed. The integral of 2x is just x squared. And we write these square brackets, and so that's between 6 and 0. So 6 cubed minus 6 squared. Subtract off, and then we substitute 0 in. And you really don't need to do this bit here, because that's really obvious that that's going to be 0. So then the answer is just 6 cubed, which is 216, minus 6 squared, which is 36, which gives me 180. Same with this one here. Let's do the integral. 6 cos 2x, we've kind of just done this. So 6, the integral of cos 2x is just going to be a half sine 2x. That's right. So the derivative of sine is cos, so that would be sine. Yep, that's correct. So, and that is going to be between pi over 4 and pi over 6. These are called the limits of integration. So we've got 3 sine 2x between pi over 4 and pi over 6. Cool. So 3 sine 2 times pi over 4 is pi over 2, minus 3 sine 2 times pi over 6 is pi over 3. Okay, so we get our exact values here. Sine of 90 degrees is equal to 1, so that's sine of pi over 2 is 1, so that's 3. Sine of pi over 3, sine of 60 is root 3 over 2. So there's the exact value of that integral there. If you wanted to do this all over 2, you could call this 6 minus 3 root 3 all over 2, something like that.